And now we're going to go over our last partial fraction decomposition example. And what happens here is we need to do some long division before we can solve the problem. So we have a dividend, and these are some math terms we use when we're dividing, and a divisor. Okay, and what we know, we need our quotient and our remainder. So I'm going to run through some long division using a placeholder as necessary. So I've got 3x squared minus 2x minus 1, and I want to divide that into my dividend, 6x cubed plus 5x squared plus 0x minus 7. All right, so I used a placeholder because I was missing that linear term. Polynomial long division is review coming into this class. But I'm going to run through my long division process. So let me see here. The first thing I will do is I will divide 3x squared into 6x cubed. 6x cubed divided by 3x squared gives me 2x. So 2x goes above my linear term, and then I multiply that 2x through my divisor polynomial expression, and I'm going to put that underneath. So 2x times 3x squared gives me 6x cubed. These first two terms should always match. 2x times negative 2x gives me minus 4x squared, and 2x times minus 1 gives me minus 2x. We always take all of that and subtract. The first two terms cancel, and then I have 5x squared minus negative 4x squared, which gives me a plus 4. I have 9x squared. And then 0x minus negative 2x gives me a positive 2x. All right? So make sure you're doing that subtraction, and then you bring your last term down. We're going to do that again. So I have 9x squared, and I want to know how many times 3x squared goes into that. And if I do that division, I get 3. So I write 3 up in my quotient. Again, I take that 3, I multiply it by this, I'm going to put it underneath. So 3 times 3x squared is 9x squared. 3 times negative 2x is minus 6x. And 3 times negative 1, we're going to have minus 3. So again, I'll subtract all of that. And when I do my subtraction, those first terms always cancel. I've got 2x minus negative 6x, which is plus 6x. So I have 8x. And negative 7 minus negative 3 is negative 7 plus 3. I've got negative 4. All right? So I'm going to pause, erase my scratch work that I did here so I have more room for working this problem out. And so what I've determined here is that I have a quotient, which is 2x plus 3, and then also a remainder, 8x minus 4. So my original fraction, rational expression that I started with, can now be written in a different manner, which allows me to then decompose partial fractions. So the way I'm going to write this is I'll write my quotient, 2x plus 3, and that's going to be plus my remainder, 8x minus 4, over my original divisor, which was the 3x squared minus 2x minus 1. So what I did, and I think I didn't say this at the beginning of the video, but the reason I knew I had to use the long division was because the power in the numerator was larger than that power, the highest degree in the denominator. I had x cubed divided by x squared. So before we could do the problem, we have to do this long division to break it down so that now I have this rational expression where it's linear over quadratic. I've got x to the first over x squared. And so at this point, what I'm going to do is I'm going to do my partial fraction decomposition for just this piece at the end. So I'm going to take just that, the 8x minus 4. I'm going to factor that denominator. 3x squared minus 2x plus 1 is quadratic, but I can factor it into a product of linear factors, which would be 3x plus 1, x minus 1. So this denominator factored into these two linear factors here. All right, so now I will set this up as my sum, and I'll say a over 3x plus 1 plus b over x minus 1. So my LCD is going to be 3x plus 1, x minus 1. And I'll multiply that through everything. 3x plus 1, x minus 1 times 8x minus 4 over 3x plus 1, x minus 1, 3x plus 1, x minus 1 times a over 3x plus 1, and a third term, 3x plus 1, x minus 1 times b over x minus 1. So some nice canceling occurs. All of these common factors cancel and our denominators go away. So I'm left with 8x minus 4 equals x minus 1 times a plus 3x plus 1 times b. So I'm going to pick two values to plug in, and the two numbers that would zero these out would be x equals positive 1 or x equals negative 1/3. And if I plug them in, I'm going to pause and plug them in. I would like you to try that on your own. I end up with a equals 5 and b equals 1. So I'm going to put that a equals 5 and b equals 1 into this expression. And this expression represents that fraction we have there. So the 2x plus 3 is still existing in our answer. And what I'll end up with here is 2x plus 3. My a value, I have plus 5 over 3x plus 1. And my b value is plus 1 over x minus 1.